Hi, 8th grade. Welcome to lesson 1-7, more properties of integer exponents. So today, by the end of the lesson, I want you to be able to say, I can write a number with a negative or zero exponent in a different way. Let's explore it. Calvin and Mike do sit-ups when they work out. They start with 64 sit-ups for the first set and do half as many for each subsequent set. So I want to set up a chart. So at the top of the chart, we'll do the set number. So the first set, second, 4, 5, 6, 7. Okay, so the first set, they do 64. Then the next set, they do half as many. What's half of 64? 32. What's half of 32? 16. Half of 16, 8, 4, 2, 1. So what conclusion can you make about the relationship between the number of sit-ups in each set? Well, each set you divide by 2. We're going to skip the focus on math practices and go straight to the first example. Example number 1, the zero exponent property. So here's another one of our properties. Marcella is playing a card matching game with some classmates. 4 matches have been made. It's Marcella's turn and she chooses 3 to the 0. What card would complete her match? So it says organize the information on a table and look for a pattern. Well, the one I know the most is 3 to the second, which is equal to 9. The powers tell you how many times the 3 is multiplied. So 3 to the second is just 3 times 3. Well, we can move up or down by either multiplying by 3 or dividing by 3. So 3 to the first power is just 3, which if you do 3 divided by 3, that gives you 1. So 3 to the 0 power is equal to 1. We could also do the quotient of powers property. 3 to the third divided by 3 to the third. Well, we know we keep the base, which would be 3, and subtract the exponents. 3 minus 3 equals 0. Well, if we were to do this the long way, all of these would cancel out to just be 1. So 3 to the 0 power is equal to 1. So the 0, this is the most important part. The 0 exponent property states that a to the 0 equals 1. Always, 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 any number raised to the 0 power equals 1. So 29 raised to the 0 power, guess what? It equals 1. 1,432 raised to the 0 power equals 1. 64 raised to the 0 power equals 1. 1 raised to the 0 power equals 1. Anything at all raised to the 0 power equals 1. So let's try it. A, B, C, and D. Well, negative 7 raised to the 0 power. Guess what? It equals 1. 43 raised to the 0 power equals 1. 1 raised to the 0 power is 1. 0.5 raised to the 0 power is 1. Anything at all raised to the 0th power is 1. Now convince me, why is 2 times 7 to the 0 power equal to 2? So, PEMDAS. What does the P stand for? Parentheses. So that means we have to do what's inside the parentheses first. Well, what is 7 to the 0 power? 1. Because everything raised to the 0 power equals 1. I'm going to drill it in your head. So 2 times 1 then equals 2. And that's why it works. Example number 2. This is talking about the negative exponent property. Simplify the expression 4 to the third divided by 4 to the fifth. Here we're going back to our quotient of properties rule that says when you divide, you keep the base and do what with the exponents? Subtract. So this would be keeping a base of 4 and then doing 3 minus 5. Well, 3 take away 5, is that a positive or a negative answer? Negative, and it's -2. Okay, let's try this the long way. 3 4s on the top, 5 4s on the bottom. These cancel out. We're left with 2 4s on the bottom, which is the same thing as saying 1/4 squared. I want you to notice a connection between these two. They mean the same thing. 4 to the -2 power, or 1/4 squared. So 4 squared is 4 times 4, which means this is 1/16, which is what they got here. Okay, so here's the most important. The negative exponent property states that a to the -n is equal to 1/a to the n, assuming that a does not equal 0. So all that's saying, and this is how I like to think of it, so stay with me here, is if you have a negative exponent, so like say we had 5 to the -3. For whatever reason, I think of negatives as being a bad thing. So I think about top and bottom. I think top is good, bottom is bad. If you're on top, you're doing good. If you're at the bottom of your class, you're not doing so good. So here, this 3 is negative, it's bad. So it's got to go to the bottom, but the 5 has to come with it. So you're going to put the 5 on the bottom, but once it's on the bottom, it's being punished enough. So it's just 5 to the 3rd on the bottom, and you have to put a 1 on top. If it makes you more comfortable, you can put this over 1 and think of it as flip-flopping them. And when you flip-flop them, the -3 becomes positive. So let's try 3 on our own. Well, we'll try 3 together because it's a new concept. Maybe we'll try 2 together and 1 on our own. So we're going to put 8 to the -2 over 1. That negative is bad, so it needs to go to the bottom. Once it goes to the bottom, it switches with the 1, but it has to bring along the 8 with it. So it's 1/8 squared. Next, that 2 to the -4, put it over 1. It's bad. We have to flip-flop it. So that becomes 1 over. Now, since it's already on the bottom, we don't make it negative. I want you to try C on your own, and I'm going to ask for a volunteer to help me solve it. So, hopefully you got 1/3 to the 5th. Example 3, expressions with negative exponents. Write the expression 1/7 to the -3rd with a positive exponent. Well, remember the bottom is bad? Well, if it's bad and it's on the bottom and it's negative, that's kind of like a double negative. So we're going to do the same thing, 1/7 to the -3rd. We're going to flip-flop them. Whenever you see a negative exponent, I want you to flip-flop. So that's going to give us 7 to the 3rd, but when you flip-flop, you lose the negative sign. So let's try it. Here, negative exponent is bad. We want to flip-flop. When you flip, it loses the exponent. Part B, same thing. You're switching the numerator and the denominator. When you switch them, it loses the negative exponent. So you can write these over 1, or you don't necessarily need divided by 1 because it'll give you the same answer. Looking at the next page, key concepts. Use these additional properties when simplifying or generating equivalent expressions. So the zero exponent property states that anything, any number at all, raised to the 0 power is equal to 1. The negative exponent property says that if you have a negative exponent, you can put it over 1, flip-flop them, and it loses the negative. On the reverse of this, I don't know why they didn't put it in. If you have 1/a to the -n, you flip-flop them, and that's equal to a to the n over 1. So this is the next one. So that rounds us up to a total of 6 exponent properties. Remember, we have the product of powers, we have the power of products, We have power of powers. And quotient of powers. And now the two that we just learned today. So going back to today's lesson objective, can we say I can write a number with a negative or zero exponent in a different way? Yes or no? Yes? Great. Okay, let's say it on the count of 3. 1, 2, 3. I can write a number with a negative or zero exponent a different way. Cool. Have a great day, guys.